Hi, I welcome you to this video. This is video number 318, and in this video I am going to use the two stages least squares as well as the instrumental variable regression to cover the problem of endogeneity. My dear students and colleagues, one of the assumptions of the classical linear regression model is that of endogeneity, that sometimes some of the regressors are correlated to the stochastic error term, and if they are related to stochastic error term, then in that case the coefficients of those endogenous variables are biased. So the idea is how to deal with the problem of endogeneity. So let me start with an example, and I would like to start with the conventional Mincer earning function. And in Mincer earning function, the dependent variable yi is hourly wage, and x1 is years of experience, and that is exogenous variable which is not determined within this model. X2 is years of education completed, but this is endogenous variable. This is not exogenous in this model. So if this is endogenous, then it violates the assumption of no endogeneity. That is, the covariance between x2 and the stochastic error term is not equal to 0. So we need to overcome this problem of endogeneity somehow. One of the ways to deal with the problem of endogeneity is to use instrumental variable instead of the original variable that is endogenous in our original model, and that is education, which is denoted by x2, and we know that the covariance between x2 and the disturbance term is not equal to 0. Think of z as an instrumental variable that we can use instead of the original variable x2, that is education. Now z would be an instrumental variable if it has the following three properties. The first property is that the covariance between the z, that is the instrumental variable, and the stochastic disturbance term is equal to 0. That is, there is no relationship between the instrumental variable and the error term. The second property of the instrumental variable is that there should be some kind of relationship or co-relationship between z and x2. So the covariance of z and x2 is not equal to 0. And the third property of the instrumental variable is that this variable is external to this model. That is, the partial of y with respect to z is equal to 0. So if any variable meets these properties, we may use that variable as an instrumental variable. That would be an instrumental variable. So in this video, I will use some instrument for education in the two stages as well as in the instrumental variable regression, and that is why we call it two stages least squares method. An intuitive approach to the instrumental variable model is with a two-step OLS approach. That is, we are using two-step OLS regressions. So let us suppose that our model is given by yi is equal to beta naught plus beta 1 x1i plus beta 2 x2i plus ui. Now yi is the dependent variable, and that denotes hourly wage earnings. X1 is years of experience and x2 is education. But we know that x2 is endogenous because the covariance between x2 and error term is not equal to 0. Then in step number 1, we will regress the endogenous variable x2 on z and x1, where z is our instrument. So then we will save the fitted values of the x2. So our model would be like this. That is, we will regress education on the instrumental variable z, and then x1 is experience, epsilon is error term. So we will get these fitted values of education, that is x2, and then we will save these values. In step 2, we will regress y on experience x1i, and then instead of x2 we will use the predicted values of x2, that is the estimated values of the education. And then it implies if we regress y on these two variables, then the beta 2 of the two stages least square will be equal to the beta 2 of the instrumental variable approach. So this is straightforward, and I have already regressed the OLS estimation of the regression in which wage was regressed on education and experience. These are the coefficients, but as we know that education is endogenous, because it has a covariance, its covariance with the error term is not equal to 0. So this coefficient of education, which is 76.21, that is biased. So we cannot use this, we cannot trust this. Then we may either use instrumental variable regression, in which the command for instrumental variable regression is ivreg, and in which wage will be regressed on experience, and then we will use the instrument, and I write within the round brackets education is equal to SIBS. SIBS stands for siblings. So we use number of children as a proxy for education, and now the coefficient of education, that is the sibling, is 139.68, which is quite different than this one. Similarly, we can also use the same thing in two steps OLS regression. In the first step, as I mentioned earlier, we will regress education on experience and siblings, and this is the coefficient of siblings and the experience. And then in the second experience, I will regress wage on experience and the predicted values of the education, and now we have this coefficient of 139.68, which is exactly the same as was in the instrumental variable regression in the previous this one, in the previous regression, which is this one, this. So this coefficient and the coefficient in this model, they are exactly the same. This one and the previous one, they are exactly the same. We will finally compare these coefficients of education, but before I do that, let me open my Stata, and I will use BCU's wage 2, and the file will come here, and this file has 935 observations, and the file size is 63,580, and these are the various variables that this file has. Let me summarize this. This is the summary table of these various variables. So I would open my do file, and first I will regress the wage on education and experience. This is OLS. I have already shown it to you in my slide. This is the OLS regression, but as I told you, this coefficient is biased. So we should remove the endogeneity from this model. So how can you do that? We will do that in two different approaches. We can use a instrumental variable regression, or we can use two steps OLS regression. First, I will store the estimates of the OLS regression, and then I will use the ivreg, that is the instrumental variable regression of wage and experience, and then sibling is use an instrument for education, and you see now this coefficient of 139.68 is quite different than this one. I will also store these estimates of the instrumental variable, and for that I will use EST, STO, IV. So these are also stored, and after this I will use the two steps OLS regression, in which first I will regress our endogenous variable education on experience as well as siblings, and then I will predict educate, that is the predicted values of our endogenous variables, and after this I will regress wage on experience and the predicted values of the endogenous variable, that is the education hat, and these are the coefficients. Now if you look at this coefficient in the two stages least square, which is 139.68, and the one that we just saw here, 139.6836, they are exactly the same. So we can do this by two different methods. Either we use instrumental variable regression or we use two steps OLS regression, and after that I will store the estimates of the two stages LS, that is two stages least square, and now I have stored the estimates of the OLS regression, the estimates of the instrumental variable regression, and now the estimates of these two stages least square. Now I ask Stata to show me the output, and here is the output. This is the OLS regression, and look at the coefficient of the education. That one is biased. This is the coefficient of education in the instrumental variable regression, and this is the coefficient for experience. Now if we compare these two coefficients of instrumental variable in two stages least square, now this one is exactly the same like this one, and this coefficient of education hat is exactly the same like this one. So you can see in both the models, that is the instrumental variable regression model and the two stages least square models, the coefficients are exactly the same. So in one we give the direct command of IVREG, and in the second one we use the two steps OLS approach. So this is how we can deal with the problem of endogeneity. When there was problem of endogeneity, this coefficient is biased, but when we remove the problem of endogeneity, so we have this coefficient equal to 139.68 either by instrumental variable regression or by two stages least square method. Now I will also do this here in my slide, and if you look at this slide, exactly as I mentioned earlier, this coefficient is exactly this coefficient, and this coefficient in the two stages least square is equal to the coefficient of experience in our instrumental variable regression. Now this is very simple, and I hope this was informative and helpful for you. If you have any question, you can ask your question in the comment section, and I'll try my level best to come up with answer. If you haven't yet subscribed to my channel, kindly do subscribe and do not forget to click on bell icon.